Hi students, welcome back to Vijay Datta chemistry classes. This is Purnima Mam. Sorry, no, the last week we didn't do any videos because we have some work. Okay, that work was completed. Okay, daily I'll upload the videos. Okay, see, today I'm going to continue the topic with the redox reactions. Means in the stoichiometry, we are going to do the types of redox reactions. Okay, let us see how many types of redox reactions we have, and let me see what are those. Okay, see here. So in today in our video I am going to explain types of redox reactions. See, already we discussed in the previous video that what are the what is meant by redox reaction. Redox reaction is nothing but both oxidation and reduction takes place simultaneously in a reaction that is said to be a redox reaction. What is oxidation reduction also we have discussed. I'll give the link in my description box about that. Okay, go and check that if anyone needs that. Okay, now come to the types of redox reactions. Here I am taking the mainly five types of redox reactions. Actually we can go for six. Let us see here. First one is the chemical combination reactions. First one is chemical combination reactions. Second one is the decomposition reactions. Decomposition reactions. And third one is displacement reactions. Displacement reactions. See here, the fourth one is disproportionation. Actually, see here, I'll go fifth one as the disproportionation because the fourth one we can write as double displacement also. Double displacement reactions. Double displacement reactions. And the fifth one is the disproportionation reactions. Disproportionation reactions. And sixth one is the comproportionation reaction. Comproportionation reaction. So these are the types of redox reactions. Okay students, without late we'll go to the each one. Okay, first now I am going to describe the first one, that is the chemical combination reactions. So let us see what is meant by chemical combination reaction. Chemical combination See, chemical combination, simply we can give the definition for this. The redox reactions, the redox reactions which the compounds are formed, in which the compounds are formed by combining two or more reactants, by combining two or more elements with each other or with a compound. So combination is nothing but two or more reactants are combining and giving only one product or two products. See, that is nothing but said to be chemical combination reactions. Compounds are formed by combining two or more elements with each other. Elements with each other. So, see, this is meant by combination. Let us see example. If I take, then you will get understand. That is, see, carbon plus oxygen, they are reacting and they are producing CO2. See here, this is a redox reaction. How can we say a redox reaction here? Carbon, it is in elementary state, its oxidation state will be zero. See here, carbon, it is in elementary state, so its oxidation state is zero. And here I can write the physical states. It is a solid, and oxygen is in gaseous state, and whatever the carbon dioxide is formed, that is also in gaseous state only, right? So carbon's oxidation state is zero. Even oxygen is also in the elementary state, so its oxidation state is also zero. Whereas come to the carbon dioxide, carbon dioxide oxidation state, how to find? We don't know carbon, then take it as x. plus each oxygen is minus 2, like that we have 2 and we don't have any charge over here, so I'm taking 0 here. Then x equal to x minus 4 equal to 0, then x equals to plus 4. So carbon's oxidation state is plus 4, oxygen's oxidation state is minus 2. So if you observe, carbon 0 to plus 4, so increasing oxidation state 0 to plus 4, carbon increasing oxidation state, so oxidation has been taken place. Comes to the oxygen, oxygen is 0 to minus 2, oxygen 0 to minus 2 oxidation state, so decreasing oxidation state, it is called reduction. So we can say it is a redox reaction. So in this redox reactions, two elements, one is the carbon, another one is oxygen, combining and forming a carbon dioxide, the single product they are forming. So these are said to be the chemical combination reactions. Okay students, we can go for the second example also. The next example I am taking over here, S plus O2 you can take. Otherwise, the alkanes and combustion, CH4 plus O2. If you are taking, always we know that an hydrocarbon on a combustion will gives you the carbon dioxide and water, CO2 and H2O. And what are its physical state? Whatever the butane, means methane we are taking, that is in gaseous state, oxygen is in gaseous state, carbon dioxide is gaseous state, and water is in the liquid state. And let us check its oxidation states. We know that CH4, hydrogen's oxidation state, because carbon is the non-metal like or metal like we are considering here non-metal, then hydrogen shows its plus 1 oxidation state. If hydrogen is plus 1, then obviously carbon shows the minus 4 oxidation state. So carbon is minus 4, hydrogen is plus 1. Oxygen is in elementary state, its oxidation state is 0. Come to the carbon dioxide, just now we have checked, carbon is plus 4, oxygen is minus 2. Hydrogen, hydrogen here, oxygen is minus 2, then obviously hydrogen is plus 1. So if you check here, there is no change in the oxidation state of hydrogen. Here hydrogen is plus 1, here is also hydrogen is plus 1 only, there is no change. But comes to the carbon, carbon oxidation state changed from minus 4 to plus 4. So oxidation state is increased. So oxidation has been taken place. Comes to the oxygen. Oxygen is 0 over here. And this side oxygen is minus 2. Even in H2O, oxygen is minus 2. So oxygen's oxidation state 0 to minus 2. Decreasing oxidation state called reduction. So both oxidation reduction taking place. This reaction is a redox reaction, and also two elements they are combining, or two compounds they are combining and forming the products. So this is the example for the chemical combination reaction. Okay students, this is about the chemical combination. Now come to the next type of reaction. Okay, I'll go with the next type of reaction, that is the decomposition reaction. Come to the second one, decomposition reaction. So what is meant by decomposition reaction? See, the redox reactions definition, if you take the redox reaction in which the chemical compounds chemically, in which the chemical compounds chemically splits chemical compounds chemically splits into two or more chemically splits into two or more simple substances, two or more simple substances. So this is said to be the two or more simple substances. This is called decomposition reaction. See here, how the decomposition is taking place. See, and also here I have to tell you, in this decomposition reaction, the splitting is not possible in the normal conditions. We have to apply some special. Special is nothing but, see here, we have a different types even in the decomposition reactions. What is that? Catalytic decomposition, that is nothing but in presence of catalysts, some of them they will decompose by heating. Those are called thermal decomposition reactions. Here it is a catalyst, if you are using catalytic decomposition. If you are heating, then that is called thermal decomposition. If you are applying any sunlight, then that is called photochemical decomposition reaction. So this one you have to apply by applying some external conditions, then the decomposition will be takes place. Those are said to be chemical decomposition reactions. If you are applying some catalyst to decompose, called catalytic decomposition. By heating they are decomposing, thermal decomposition reactions. By applying sunlight they are decomposing, those are called photochemical decomposition reactions ma. Okay, now come to the examples of decomposition reaction. I am taking here KClO3 produces KCl plus O2. Always we have to balance the equation. Okay. See here, that to balance the equation I am taking like this. And even oxygens are not balanced, so I will go with the 3O2. And also one more example also I want to take. This is the first. And one more example is H2O. This is also decomposition is taking place. Then it is H2 plus O2. See here. Simply we can say, we can calculate its oxidation states, and also we can go for either it is decomposition. See here, oxygen is 0, hydrogen is 0, whereas come to here, oxygen is minus 2, hydrogen is plus 1, isn't it? See, decomposition, either it is a redox reaction or not, we have to check. So the redox reaction if you are taking, so hydrogen's oxidation state, if you are considering hydrogen, it was changed from plus 1 to 0. Plus 1 to 0 is nothing but decreasing oxidation state. Decreasing oxidation state is called reduction. So decreasing oxidation state is called reduction over here. Comes to the oxygen. Oxygen's oxidation state minus 2 to 0. So increasing oxidation state is called oxidation. So it is a redox reaction. In this, the water molecule has been decomposed to H2 and O2. Okay. This is also example for decomposition reaction. Even KClO3 decomposed to KCl and O2. Here we use the catalyst ma. Which catalyst we use here? MnO2, manganese dioxide, that one we'll use for the reaction. Okay, see catalytic decomposition, like we can say again catalysts are two types ma. That is again we'll discuss, that is a separate topic. Again we have a positive catalyst, negative catalyst, those only called as the inhibitors, promoters, like okay. So that is again the different theory. Here the decomposition we are discussing. As we want to know the oxidation states, potassium is plus 1 oxidation state. You don't know chlorine's oxidation state, then simply how to find plus 1 plus x plus minus 2 into 3 equal to 0. Then minus 2 into 3 minus 6 plus 1 minus 5, x minus 5 equal to 0, then x equals to plus 5. So chlorine's oxidation state is plus 5, oxygen is minus 2. Whereas to come here, chlorine, potassium is plus 1, chlorine is minus 1. Oxygen is in elementary state, its oxidation state is 0. So you can write potassium plus 1 plus 1, there is no change in the potassium. Whereas come to the chlorine, chlorine is said to be has been changed from plus 5 to minus 1. Decreasing oxidation state, reduction, which is getting reduced, those only called oxidizing agents also. This is also we discussed. Oxygen if you are taking, then oxygen's minus 2 to 0, increasing oxidation state is called oxidation. So this is the redox reaction, decomposing or splitting into two or more simple substances in under some conditions, those are said to be the chemical decomposition reactions ma. Okay, now come to the next type of reactions. Next type of reaction is the displacement reaction. Next one is the displacement reactions. See what is meant by displacement reaction. The redox reactions in which one species displaces other species. One species displaces other species. Ma, again here it is not a simple just like that. See, I'll write here two reactions. Then you may understand that why it is not a simple like. See, zinc plus CuSO4. I'm going with the example. Copper sulfate gives rise to ZnSO4 plus Cu. Whereas come to here, I'll write one more, Cu plus ZnSO4 gives rise to CuSO4 plus Zn. Out of these two reactions they'll give, but only one is the correct, another one is not possible. Why? Because while always doing the displacement reactions, one species is displaces the other species. Here zinc is displacing the copper and it is forming zinc sulfate and copper is coming out. Whereas come to the reverse reaction, just copper cannot displaces the zinc ma. If anybody writes the reaction like this, are they given which of the following is the correct reaction, like if they given this one, this is not, because copper plus ZnSO4, if you take one container, in that you take ZnSO4 solution and dip the copper rod, then it cannot turn into the blue color solution. Copper cannot displaces the zinc, because copper is the least reactive metal than the zinc. So the important thing what we have to remember while displacement reactions, highly reactive metals can displaces the less reactive metals, but less reactive metals cannot displaces the highly reactive metals. This order we'll discuss in the electro chemistry. In electrochemistry, electron reduction potential, standard electron reduction potentials, like we'll study the same order. Here I'll give you the small glimpse, that which one is correct. See first, potassium, sodium, calcium, magnesium, aluminum, iron, zinc, hydrogen, and then copper, silver, gold, silver, gold means Au, and platinum. These are the general metallic order. It is, see here only the thing over here. Yes, only the thing. See, these are the highly reactive metals, and these are the less reactive metals. It is the standard reduction potential value for hydrogen is zero, actually. Okay, it is zero. And whereas come to the copper, silver, gold, and platinum, see, these are the cost, more cost. Why silver, platinum? Silver, if you are wearing the ornament 2 to 3 years, otherwise after 6 7 months it turns the black, because it is getting oxidized slowly. Whereas come to the aurum means gold, even if you are wearing this it don't loses its shine, because it is not reacting with the atmosphere. All the gases are any oxides present in the atmosphere, they are not reacting. Even platinum won't react, that's why it is more cost than the aurum. Nowadays platinum ornaments are going famous, because it is more cost, more expensive, because it is highly inert metal. Au also inert metal, so these are less reactive. These metals cannot displaces the highly reactive metals, but highly reactive metals can displaces the less reactive metals. That's why zinc can displaces the copper. That's why first reaction is possible. Whereas come to the second reaction, that is not possible, because copper cannot displaces the zinc, because it is the least reactive metal. Only that is the reason we should know while discussing the zinc displacement reactions, okay. So these are the highly reactive metals can displaces the low reactive metals. This is no reaction is possible for this. This reaction is possible because zinc is highly reactive, copper is less reactive. So zinc can displaces the copper. Comes to this reaction, copper is less reactive, zinc is highly than copper. So copper cannot displaces the zinc, right? Such reactions we have some more reactions also. That is zinc, if you are taking reacting with HCl, then it forms ZnCl2 plus H2. See here hydrogen is, we know that is zero. It's a standard reduction potential value. So it is a reference like we can take. So it can displaces like this. Okay. So these are the displacement reactions. Uh, the video becoming lengthy, so I'll go for the types of redox reactions part 2. Okay, this is the part 1. In this we can calculate its oxidation states also, zinc is in elementary state, so its oxidation state is 0. Whereas come to the copper, we know that copper shows here +2 oxidation state. Sulfate ion SO4 2 minus, overall it is called radical, see, chlorine having minus charge, it is called ion. And Na having positive charge, it is called ion. But PO4 3 minus, excuse, PO4 3 minus, like that is, it is nothing but group of atoms. Five atoms are there, one phosphorus, four oxygens, five atoms are there. So it is the five atoms, a group of atoms are having some charge, so these are said to be radicals. So sulfate ion, this minus 2 charge belongs to all SO4 ma. Okay, SO4 minus 2. See here, individually also you can calculate, we can get the same because sulfur is plus 6, so oxygen is minus 2, minus 2 into 4 minus 8 plus 6 minus 8 minus 2, the same. Zn plus 2, SO4 minus 2, copper is 0. So if you understand, zinc 0 to plus 2, increasing oxidation state, copper plus 2 to 0, decreasing oxidation state. So oxidation reduction is going on, so we can say it is the redox reaction. So in this video, we have discussed chemical combination reactions, decomposition reactions, and displacement reactions, right? In the next video, double displacement reactions, disproportionation, and comproportionation we'll discuss. Okay. Thank you, students. Please, if you need any topic, please write on the comments box. Definitely, I'll go. And also, please like, share, and comment the videos, and please subscribe to my channel to get more conceptual videos. Okay, students, thank you so much.